In level 4, we're just going to bump it up to the next level and solve some more difficult log equations, but kind of using some of the same properties from level 3. So in this problem, I'm going to want to combine my logs into a single log, so I want to move this natural log of 4 over to the left side of the equation. So I'll get natural log of y minus 3 minus natural log of 4 equals negative 2x. And then using the quotient rule, since these are subtracted, I'm going to divide the insides, and I get natural log of y minus 3 over 4 equals negative 2x. Next, I'm going to change this to exponential form. So remember that this means log base e of y minus 3 over 4 equals negative 2x. So changing it to exponential form, I get e to the negative 2x equals y minus 3 over 4. I'm trying to solve for y, so to get y by itself, all I have to do is multiply both sides of the equation by 4, and I get 4e to the negative 2x equals y minus 3, and then I would add 3 to both sides. And we get y equals 4e to the negative 2x plus 3. So I got y by itself. My expression has x in it, but that's okay because my goal was just to get y by itself. I was supposed to solve for y. To solve this next equation for x, x is in the exponent. The exponential part is all by itself, so I'm going to try changing this to log form. And I get log base 2 of 7 equals 5 minus x over 3. And then to solve for x, all I would have to do is subtract 5 from both sides. And we get log base 2 of 7 minus 5. We put the 7 in parentheses so we know that the minus 5 is outside of the log, equals negative x over 3. And then if I multiply both sides by negative 3, I will get x by itself. So we get negative 3 log base 2 of 7, and then distributing that 3, we would get plus 15 equals x. And then it says to round this answer to 3 decimal places. So since this log right here is not, we don't have a button for log base 2, we have to use the change of base formula. So remember the change of base formula. You can use either the log button or the natural log button, and we do log of the big number 7 divided by log of the base. And so that's what we would plug in our calculator, plus 15, and we get approximately 6.578 would be rounded to 3 decimal places. This next one is kind of a tricky example. We are actually going to solve this exponential equation by factoring. And the way it's going to work is if I wanted these two parts to multiply to 2 to the 2x, I could put 2 to the x times 2 to the x. If those were multiplied together, the x's would be added to give me 2x. And if I do a plus 3 and a minus 2, this gives me 3 times 2 to the x. This gives me negative 2 times 2 to the x. And if those were added together, that gives me positive 1 times 2 to the x. And then my last two numbers multiply to negative 6. So I have now factored this, and we set it equal to 0. And then what I'm going to do is solve each little equation. So 2 to the x plus 3 equals 0, and my other equation is 2 to the x minus 2 equals 0. To solve this, I would subtract 3 from both sides, and we get 2 to the x equals negative 3. And then I'm going to change it to log form. So we get log base 2 of negative 3 equals x. And we can't take the log of a negative number, so this is actually an extraneous solution. So I go to my other equation and I add 2 to both sides, and we get 2 to the x equals 2. And then this one I can actually do without changing it to log form. 2 to what power equals 2? Well, x would have to be 1, because 2 to the first is 2. And that's my answer.